好，各位参会代表，大家好。因为时间到了1点半，我们就
Dear
正式。
delegates, we will start
大家好，
this session.
欢迎大家参加今天的
I warmly welcome all of you to the Breakout Session 1. I am the moderator,
Recording in
and
progress.
I am the AA's representative.
会议正式开始之前呢，有3个会议事项，想要和大家做一下。
I will have 3 notices for the housekeeping for you.
大家可以看到地球
In the function, we have the interpretation, and we provide the Chinese, English, Vietnamese, and Mongolian. So you can select the channels as you like. And the second, the housekeeping is that during the conference, we have the different channels to listen to the presentation, including the Zoom platform, the website, and also CAA WeChat account, and the environmental post. So on the stream platform, every day we have 5,000 visits. On the website, we also have 400 visits. So if you would like to use the different channels, please feel free to select the channels convenient for you. And if you need to raise questions, you can type your questions in the chatting box, and we will collect the questions and our presenters will answer them. And here we also have a questionnaire for you. We hope that our participants can spare some time to fill this questionnaire. I will give the floor.
Hi, can you hear me? 你好，请总部的同事来去和大家介绍一下问卷填写的事项。
Hello, our interpreter. Please tell us about the questionnaire and how to fill it.
不好意思，可能是现在还
Sorry, maybe they are not connected now. So I will briefly introduce to you. During this conference,
在这个会议过程中呢
during the conference, you can select the interpretation function according to the channel you need. And you can also type your questions into the chatting box. And please set Evelyn, my colleague, as the co-host. And Evelyn will introduce to us how to fill in this questionnaire. Please wait for several minutes.
Hi, Evelyn. Can you speak now? I already set you as the co-host.
So hi everyone, welcome. And before we start, we are kindly requesting participants to answer the pre-test, which will be launched via Zoom poll. So now we are just waiting for the poll to launch. And okay, now what you will see in your screens are a very short number of questions, and we would like you to just click on your response. So you would see here there are 6 questions, such as how would you assess your knowledge on policy development and best air quality management practices on the energy sector. And then you can choose based on the rating scale, with 4 being the highest and 1 being the least. And the same question can be read for the transport sector, for clean cooking and heating, and practices on agricultural waste utilization, on urban waste management, as well as on brick kilns. So we're just giving a bit more time for our participants to answer this very quick survey. And later on, towards the end of our workshop, we will give you another post-meeting evaluation just to assess if your level of understanding has increased on these particular topics. So thank you very much. Right now we have 8 out of 27 of our participants, just giving a few more minutes to answer the poll. So again, this is just a very short assessment that we are trying to do so that we also know how we can maximize learning opportunities for everyone as we go through the very interesting sessions that we will have in the breakout sessions. We now have 10 out of 27 participants. We're hoping to have at least half of our participants to answer the survey.
Evelyn?
Okay. Yes,
Yeah,
I think we
shall we
can
start the
end
meeting?
the call now.
Okay.
So we can start with our interesting sessions. Thank you very much, everyone. We hope you stay until the end and answer the post-workshop evaluation later on. Thank you very much.
好的，好，谢谢大家，填写问卷，那么接下来呢，我们就正式进入今天的会议日程。分会场
Now
一呢，
we officially start today's presentation. Our breakout session will look at the transportation and the power generation, because these are very important two sectors in the carbon emission reduction and air quality management. Yesterday, we have listened to the presentation about the policy framework and the legislative development. We also need technology to support it. So we are very honored to have our two experts in the power generation and transportation and 6 representatives from the enterprises to tell us about the best practices. So we have several sessions. The first one is the technology export presentation, and the second part is the presentation from the enterprises. After these two parts, we will have a short break, and you can use the break time to participate in the closing ceremony here. And first, let's talk about the power generation. In the power generation, China has the most stringent requirement on the thermal coal and the emission-related requirements. And we will have Professor Wang Zhixuan from North China Electric Power University, and he will talk about the best practices and the development technologies in China. So, can you hear me? Okay. Good afternoon, ladies and gentlemen, and dear colleagues. Today, I want to talk about 4 major aspects. The first is we will look at the prevention and control of the electric power air pollution, and the second is the control technology. And then I will talk about the experiences. So first, I would like to talk about the basic situation. We first need to know about the energy consumption and the big pictures in China. The upper right is a record from 1978 to 2020, and you can see the energy consumption in China. The red one at the bottom is coal, and the upper ones are oil, natural gas, hydro, nuclear, and other renewable energies. So with this, we can see that in the past 20 years, from 2002 to now, we can see that for the energy consumption, the growth is very fast. And so please get rid of the questionnaire.
哎，麻烦您重新共享。
So please share your screen.
现在还没有看到您的共享屏幕。
他刚才讲的时候，突然把那问卷怎么能够显示出来？好像没有忘记。
再说一声，
Okay, please wait for a moment, and we need to share the screen.
好的，请大家稍等一下。我们
Okay, please be patient and wait for a little while.
马上，可以了吧？
稍微有现在可以了。
Okay.
好，那么从这个图里面还
So from this graph, we also can see that
现在呢，仍然
for the coal consumption, it is if we look at the data of the end of last year, it is still the biggest part, and it was 56% of the total. And the total consumption is 5.24 billion tons of the standard coal. And from 2013 and above, so we can see it has gone through the peak, and the curve is getting flattened. In the past over 1 year, we see that the energy consumption are mainly increased in the sector of the new energy. Although the total consumption is getting higher, the share of coal consumption is getting smaller and smaller. Renewable energy is getting a bigger and a bigger slice. If we look at the power generation, we can see that the thermal coal power generation is 60% of the total. And the installed capacity is about 56% of the total. So if we look at before 2008, that percentage was 80%. So now you can see a significant decrease. Here we have 3 pictures. They are representing the current technology of the thermal coal power generation. The first one on the left, it is the first million kilowatt double reheat unit. The generation efficiency is 47.9%. The designed coal consumption is 256.2 grams per kilowatt hour. In the middle, this is the world's largest CFB boiler with a low calorific value fuel, and for the unit capacity is 660 megawatts. It also has the limestone desulfurization, FGD, and SNCR. And it also has a reservation of 1 layer SCR. On the right, it is the world's first 100 megawatts ultra supercritical air-cooled generator unit. After the construction completed, we also have got the cogeneration modification. So it is now transmitting heat to Incheon City, which is 50 kilometers away from this project. And we also can see this pollution. We can first look at the thermal efficiency of the coal-fired power plant. The red curve on the left is China's power generation efficiency improvement. In 2006, so we see that the coal power generation efficiency is the same as that of the USA. So that is 360 grams per kilowatt hours. And after that, the improvement is continued. And now we can see it is at the same level of Japan, which represents the top, the most advanced efficiency. On the right, it is the comprehensive thermal efficiency of the coal power heating unit and the comparison with other countries. From this graph, we can see that the coal power heating, its power generation percentage is 50% of the total, which means that over half of the power generation has the coal generation. And for the other countries, the coal is mainly used for the power generation. And if you look at German and OECD, its share of the coal power heating is much lower than in China. It is the same for the USA. So this is the main pollutant emission node of the coal-fired power plant. On the right, we can see that in the different season, this is a record of the pollutant, which can show how it is generated. If we look at the pollution control in China, on the right, we can see a graph. The red one is for the thermal power increase of the pollutant. 90% of the thermal power in China is a coal-fired power generation. So in China, we can say that the coal thermal power represents the whole thermal power. And on the up, that is the black one, that is for the SO2, and the blue one is NOx. And also the gray one at the bottom is the dust. So you can see that the pollutant emission is getting decreased. In 2006, we see the peak of SO2, and also in 2011, the NOx has reached the peak. And currently, the total emission is less than 2 million tons. On the left, we can see a list of a figure that is per kilowatt-hour pollutant emission record. If we look at the thermal coal power generation, we see that China represents the lowest emission. This is the low nitrogen combustion and the development of the progress. So from 1990 to 2005, we started to use the low NOx combustion, while at the same time to have the higher level of dust control. From 2006 to 2020, we started FGD. From 2011 to 2014, we started the SCR, and that is for the smoke denitrification. And in 2015 to 2020, we promoted the ultra-low emissions of PM, SO2, and NOx. For the dust removal, in the early 1990s, we mainly used the mechanical dust removal efficiency.
Recording in progress.
就是开始普遍的采用电储存器，那个效率呢是98%。又过了10年，2010年的时候，就是更为高效的储存器。这个时候呢，包括了一部分带式储存器，当然还是电储存器为主。同时呢，也出现了带式和储存器复合型的，叫电带复合储存器。那么当前呢，主要的还是电储存器、电带复合储存器和其他高效储存的这么一个方式。左边的图就是它储存效率提高的基本的情况。那么储存器基本上呢采用的这个图可以看出来，像电储存器中间是带式储存器，然后从左到右第三个是电带复合储存器，就是电储存器和带式储存器的结合，充分利用了它们二者之间的优势。那么最右边的叫湿式电储存器，这个主要是在超低排放开始要求之后呢，对于气溶胶和其他更细粒子的一些去除。关于二氧化硫这个治理的这个图呢，我想简单的介绍一下。横坐标是年份，纵坐标是二氧化硫的治理以后的排放的浓度。 然后中间的曲线呢，就可以看出来啊，随着时间的推进，最上面的这个排放标准的趋严，那么采取了不同的污染控制技术，使得二氧化硫的浓度直线就快速的下降。那么在90年代之前上一世纪90年代之前，我们开始呢是自主研发脱硫技术但是很遗憾呢，这些自主研发的脱硫技术基本上就没有用。为什么呢？因为当时研发的时候，主要的是希望能够采用一种比较低成本的，但是治理措施也不要太高的。但是随着中国燃煤电厂的建设环境保护要求趋严，所以研发的技术呢满足不了当时环保标准的要求，所以呢就开始引进技术。初期呢也是进行了一些合作，比如说给日本利用它也是当时的绿色资金叫绿色援助计划的资金进行了电子束脱硫炉内这个旋转喷雾脱硫几个方式的试验我当时也是代表中方是作为这几个试验示范项目的负责人。但是呢，这个技术呢最后也没有使用，其主要原因呢就是虽然便宜，但是这个脱硫的效率不是太高实际上呢，这一点呢，我想讲一下，就是一开始我们想发展中国家是不是我们可以用一些比较便宜的技术，但实际上呢，这要看你具体的当时的环境保护的要求。所以很快的呢，中国就采用了直接来引进成熟先进的脱硫技术。所以到了2003年到2011年期间呢，是技术快速发展的时候。当然引进了技术之后，当时引进技术的成本也是很高的包括到中国之后呢，根据中国的煤脂和它的整个的机组的情况各环保的要求进行了不断的创新和改造。所以到最后面的超低排放技术阶段所用的技术呢，基本上就是有很大的都是中国自主研发的。因为世界上的其他方面的脱硫技术呢，也没有要求那么高的脱硫的一个效率这个大体上呢就是这么一个趋势那么在于这张图呢，就是这个 PPT 呢，主要是说了三种工艺因为后面的专家还要介绍具体的情况，我简单的就讲一下。最左边的就是我们普遍采用的石灰石石膏法石法脱硫技术，中间的是海水法烟气脱硫技术，最右边的是氨法脱硫技术这张图呢，主要是说明我们在储存器改造特别是这个不是脱硫石法脱硫的脱硫塔改造的时候，怎么能够提高效率的呢？比如说采用有的是托盘塔就是塔里面有托盘，实际上是塔板托盘塔，旋会耦合塔这是中国自有的发展的技术。还有双循环液柱串联塔以及单塔串联等等多种技术提高脱硫效率。这张图呢和前面的图有类似，就是说是烟气脱硝氮氧化物控制的一个过程。氮氧化物的控制呢，中国也是经过这么几个阶段。最初的时候主要就是要采用这个改变燃烧方式用低氮燃烧器这种方式来降低氮氧化物的排放。但到了2003年到了2011年这个时候呢，就开始从国外引进SCR 这个脱硝技术然后呢就是整体来说它这个与脱硫的进程可能晚5年就并不是说是脱硫脱硝并没有同步开展，就是先脱硫后来差5年来进行脱硝的 到后面脱销里面除过，那么怎么提高它的效率呢？主要可能就采用包括是对它的流程进行了优化啊，因为脱销的流程是有优化是非常重要的，然后就是催化剂啊，催化剂和酶酯的匹配，等等啊，采用这种方式啊，这是脱销的一个进程，那么对于元气脱销的技术呢，是可以说主要是两类了，一类就是SCR 啊，就是烟气脱销，另一种是 SNCR 啊，在有时候呢，这两种技术呢还在联合运用，比如说对于一些无烟煤啊，特别是氮氧化物产生量高的啊，有时候可能需要啊 SNCR、SCR 联合来进行使用。右边的呢，这就是它脱销的一个流程，一个系统图，那么在进行污染控制的时候，这个企业它的自主性或者积极性，它实际上既有被动的要求，它也有主动的。被动的那就是强制性法律法规的要求，你达不到，那就是超标排放。当然，如果仅仅是这样的要求的话，中国也不可能这么快的来推进，这么短的时间达到这个效果，那就是环保电价。那么环保电价呢，我们做过专门的调研啊，这个调研呢是应该说是非常大的一个规模啊，涉及到中国的绝大部分的脱硫、脱销和除尘装置。这个调研的目的是为了政府来制定脱硫脱销电价啊，当时也是我牵头来做的。从这里面可以看出这个规律啊，一个就是随着机组容量、单机容量的扩大啊，它是每千瓦时的污染控制成本在降低啊。这个图呢，它是个成本的一个图啊。再一个呢，就是除尘的话，你怎么能够把除尘的能够区分开呢？除尘它本来就跟整个工业系统是连在一起的。它和脱硫脱销还不完全一样，因为没有脱硫脱销，我电厂可以运行，但是你没有除尘器的话，你怎么运行啊？所以除尘的这个成本啊，主要是就是比如说我按99以上的啊，大体上就是更严的标准，比如说50毫克，我这个不给你补贴，但是你到了30毫克的要求的时候，或者20毫克的话，那是给多少呢？实际上政府给了。每千瓦时2厘钱，就是就是0.002，这个元，这是这么一个大体是这么一个解释吧，基本上政府给的补贴呢，从我们调查的结果来看，基本上是对的是30万千瓦等级的，得脱硫的给1分5啊，脱销的是给了1分钱啊，除尘的是给了2厘钱，再加上超低排放之后啊，加了1分钱啊。当然了，机组越大啊，它整个的这个成本是下降的。当然，这里面也与煤的含硫量有关系。这个图呢，基本上含硫量是在煤的含硫量在1%啊偏上一点，大体是这么一个情况。下面我要介绍一下电力的节能减排技术。节能减排啊，在中国实际上和国际上的说法还不完全一样。节能主要是提高效率啊，怎么能够减少二氧化碳的排放？这主要是节能的效果啊。减排主要还是讲的是污染物。这一块讲的呢，主要是通过对于工艺流程的改变啊，来提高效率。这里面有热电联产，我前面讲到了热电联产是中国的一个特色。因为热电联产，它可以使煤的热能的利用率达到85%啊，就是它除过发电以外，所以这是一个非常好的一种技术啊。再一个超临界发电技术啊，中国的为什么在世界上现在最先进的呢？最重要的就是后期新建的基本上都是超临界的发电技术。生物质耦合这个呢，主要是从对于提高效率，同时呢，最主要的还是从降碳啊，减少二氧化碳的排放和生物质来进行耦合的技术。发电设备的节能改造里面有低温赏煤器，这主要是提高 余热的利用啊。现在呢，应该是特别是低碳发展要求以后采用这个大型的热泵尽可能的使电厂的余热利用，也是一个非常好的一个方向。这个电厂的一些电机采用了变频改造，这个储热技术，这个热电解耦，实际上这是对热电厂，尤其是大规模的可再生能源发展之后中国的燃气的电厂的比例机组的比例只占到5%，就是进行灵活性调节的时候，它需要用煤电机组来调节，因为天然气气电不够。在这种情况下，那你供热电厂它怎么来进行调节呢？那就是把热和电给它分开，也就是说，在你发电低谷的时候，然后呢，它可以用发电的部分去加热，储热，然后到了需要热的时候，这个时候又不需要电的话，那么它就发电，它就是降低这个负荷，实际上对热电厂的热电之间进行解耦这是这个储热技术的运用对于14.5煤电机组呢，现在我们最新的提法叫3改联动。第一个呢，就是进一步提高煤电机组的效率这种改造第二个呢，就是热电联产的改造，因为我们还有很多的供热是采用工业锅炉甚至散烧的煤炭希望要进一步加大热电联产的推进第三呢，就是灵活性改造，就是本来你机组这个纯凝气式的煤电机组它一般调节的时候能调节到50%这个负荷率，现在呢希望能够把它往下再能够达到30%就是往下降，有的可以说灵活性改造能够让它到20%的时候还能进行调节。这个做法主要是为了适应新能源的这个发展。那么要说有经验的话，我们认为第一个就是排放标准的要求不但趋严从前面的几个图里面都看出来，它随着排放标准的趋严所以这是一个最基本的一个要求，但同时有环保电价加超低的排放的电价。这一点呢，我想简要解释一下，就是因为中国的电价特别是过去不论是消费电价还是上网电价都是政府控制的当然是随着电力市场化的推进现在电价呢朝着市场化的方面发展，但是有一些电价仍然还是要政府控制或者叫政府调控。那么环保电价它之所以为什么说环保本来就是你电厂污染，为什么治理还要给你电价呢？是因为当初在批准建电厂的时候并没有那么严的环保要求，等建成了之后环保要求严格了，当然原来确定的你当时的电价肯定是没有把环保因素放进去，所以这时候是要给企业要进行环保电价的补偿。那么补偿的基准是什么呢？就是说基本上就是按照你环保治理的成本来进行补偿的。在这种情况下，加上企业的环保的理念，加上法律的要求，再加上经济电价支撑，所以它才能推动。所以我们一直在研究，没有环保电价或者环保电价低的时候能不能这么快？我来回答就是不会有这样快。为什么呢？那企业它确实存在着很大的困难。再一个呢，就技术引进一定要结合自己的情况，还要进行自主创新。要不创新的话，你不可能满足中国日益趋严的环保技术的要求当然通过了创新的加上自己的设备的不断的改造，它总体上的成本是下降的。但是我想在此呢，也想给提一点建议，就是我们虽然走过了这条路这是我们自己的一些经验，但是反过来说如果我从今天如果在考虑我们过去是否也有存在问题的时候当然也有，就是说我们现在比如说我们要充分考虑到低碳发展 的要求对于我们脱硫除尘它要求的这个影响，因为我们在脱销的时候，并没有考虑到二氧化碳的这个问题所以说呢，下一步如果要再进一步要进行烟气脱硫脱销的时候，要和二氧化碳的控制的要求怎么能够让它更有效率？技术在不断的进步，所以呢，中国的这个经验，我认为也不是完全的就合适。另外呢，还有一点最后我想再说一点，就是到现在为止，我们仍然还有数亿吨煤，比如说有三四亿吨煤，还是处于散烧的状态，就是直接用于老百姓就居民特别是农村的居民来烧。那么这一部分呢，从一般的发展规律上来说，应该首先是解决散烧的问题然后呢，逐步的再提高污染治理措施。而根据中国的特点呢，我们首先是在燃煤电厂，而且呢，排放标准是越来越严。实际上在一定程度上这个对于燃煤电厂的治理的要求是提前超越了其他方面的要求。那是不是这一点在各个国家情况可能也不一样这是我想提的一点建议。那么面向未来，那么烟气治理方面还有没有进展？我们第一个就是要在重金属方面要有所突破。但是呢，有一点，这个突破是什么呢？我们这个写法叫做成为新的关注点。为什么叫关注点而不是直接的治理措施呢？因为脱硫、除尘、脱硝，它本身就是能够对烟气中的汞及其化合物去除的措施这过去发达国家他们也是这样的。那么但是呢，我们还要进一步的要研究，那么它到底它的去除率怎么样，还有多少，我们怎么采取措施，这是下一步要做的事情。另外下一步呢，还是要把废水治理呢，中国也非常重视，但是我还要考虑到，就是基本上是要废水是不外排的，但是你不外排，你也不能无限循环那么其他的最后处理的其他的可溶性盐类或者其他的废物怎么考虑，这也是下一步要考虑的问题。另外固体废弃物的治理，因为社会人石膏法其他还有一些方法，它把二氧化硫这个去下来，但是呢，它产生了大量的脱硫的石膏。这种固体废弃物的利用因为在发展阶段呢，有很多的筑路建材要用，但是随着逐步饱和的话，这也是一个问题。所以呢，能够少产生、不产生这个废弃物的治理技术呢，可能也是需要进一步发展的。另外呢，随着环保要求的进一步趋严标准也在变化所以说还要研究它进一步趋严之后采用什么样的一个技术。好，谢谢。
好的，谢谢那个王教授您的精彩分享。从您的分享中，其实也可以看到非常鼓舞人心的消息，就是发电量的增长，它其实跟大气污染物的总排放量已经是在脱钩并且三项污染物的排放很早以前已经达到了这个达峰。那么非常感谢您的再次感谢您的这个分享。在咱们 Zoom 聊天Zoom 会议室和直播后台观看的这个参会人员，如果您对王教授的这个分享有任何的想要请教的问题，或者是说想要讨论的想法，都欢迎大家发在聊天室和这个直播后台的评论区。好的，谢谢王教授，您可以就是结束您的共享了。好的。其实在整个的我们的中国过去几年的这个污染治理中，除了电力领域之外，中国在机动车的污染控制上也下了很多的重功夫。过去20年来，中国机动车的排放标准是经历了从无到有，从国1到国6这样的一个历程，技术呢也更加的成熟。所以我们今天也非常荣幸请到机动车排污监控中心 BECC 的倪虹研究员倪主任为大家来介绍机动车技术它的发展和应用。倪主任您请。
可以看到屏幕，听到声音吗？
可以，很清楚。
好的，尊敬的女士们、先生们，尊敬的专家领导们，下午好。 很荣幸啊，能在今天再次见到大家，跟大家分享一下机动车排放控制技术相关的这个内容。那么在昨天的讲座中呢，我已经对这个我们中国移动源排放的整个的进程，以及管理的体系，做了一个介绍。那么今天呢，我们就专注于控制技术这方面的内容。我介绍的内容呢，主要是包括2部分。一部分呢就是汽车的排放控制技术，那么另外一部分呢就是汽车的检测监管技术。因为呢这个排放这个移动源的排放控制技术的这个达标情况、达标监管呢跟这个固定源有很大的区别，因为是非常分散，而且是在移动过程中的，难以监管。所以我觉得为了实现真正的减排目的呢，发展好的汽车检测监管技术呢也是非常重要的一个内容。那么首先给大家介绍一下尾气排放控制系统的那个总体的一个原理。
倪主任，不好意思，您可能不小心摁到了静音，请您再解除一下静音。
好，
可以了。
我们移动源的排放控制技术呢，跟固定源其实是非常相近的。它的这个污染物的产生呢，都是在燃烧过程中发生的。那么呢，我们是对燃烧产生的尾气呢，做一些氧化还原以及过滤的处理呢，去净化这个尾气。那么跟固定源不太相同的地方呢，就是我们移动源是在移动，它的那个工作特征。它的这个工况呢是不稳定的，有的时候负荷非常低，有的时候负荷又特别大，而且呢，它工作的环境也不一样。它可能今天是在平原地区，等明天呢，它就上到过2天呢，它就上到2400米高海拔地区了。那么温度也是不一样的，可能是从40-50度到-20-30度，在这样的环境条件下呢，都是要工作的。这是首先是跟固定源的一个差别。另外第2个差别呢，就是我们所有的控制装置都是装在车上的，它需要集成度非常高。那么所以呢这就导致了我们移动源的排放控制的体系呢，跟固定源呢还是既相同，但也有自己的特点。总体来说呢，这个我们在做排放控制的时候呢，从这个污染物的产生过程以及后面的净化过程呢，我们都就是都要实施以技术手段进行控制。那么首先呢，是在燃烧过程中呢，我们是对影响燃烧的这个燃料和空气，也就是说它燃烧的这个反应物质啊，我们要进行控制。那么也就涉及到的车上的排放关键控制部件呢，就有燃料的喷射系统、废气的再循环系统，以及控制进气压力的这个增压器，以及进气的这个方式啊、混合均匀度等等的这个节气门进气系统的这个物理形状的这个设计等等。那么在发动机内燃烧的过程中呢，通过设计发动机燃烧室的形状，以及点火的时间、点火的能量、配比燃料和空气的比例等等呢，我们又可以控制这个燃烧的方式，使它燃烧更完全，或者说使它空燃比有所改变。那么设计的关键部件呢，就是发动机内部的这个气缸盖啊、活塞啊等等的。另外很重要的就是我们现在都是电控系统，那么就是利用车上的各种传感器获得的信号，我们计算出来需要发动机进行怎样的燃烧呢？再反馈到相关的执行件上去。那么出来的这个排气呢，在进入到后处理系统之前呢，我们往往还要考虑到它就是为了在后处理系统中能够反应的更加完全，我们还要考虑它的一些物理性能，比如说温度啊、流速啊、空燃比等等。 那么我们也要考虑这些排气成分，就包括你有哪些未完全燃烧的燃料是在后面的，还可以作为后续的一些原料继续反应的。那么呢，还有一些氧气的含量啊等等的。那么在这个排气的这个过程中呢，我们也有一些关键部件是对它进行控制的，比如说保温层，是吧？我们要保持发动机排出尾气的一定的温度，来促使后处理器呢能够得以工作。另外呢，有的时候我们还会在排气管中加装喷嘴儿，这个喷嘴儿呢有可能是燃油喷嘴儿，它是为了给那个后处理的 DPF 颗粒捕集器再生的时候呢提供这个燃料而添加的。有可能呢是尿素水溶液的喷嘴儿，它是为了 SCR 能够正常工作而添加的。那么到了好不容易到了后处理系统这一块呢，那么我们的后处理系统呢就是相对来说就是比较复杂了，它既有氧化性的做氧化反应的，也有进行还原反应的，那么还有物理过滤的。经过这一套复杂的过程之后呢，尾气呢就能够得以净化了。那么有的时候我们在讲排放控制技术的时候，非常关注这些关键部件说采用了哪些技术，但是实际上除了它这个车上装了什么关键部件之外呢，我们还要关心这个车它是不是对一些控制要素进行了良好的设计。如果不能很好的控制的话呢，比如说它即使有一个 SCR， 但如果它不能给 SCR 提供很好的这个工作条件，那么这辆车它的氮氧化物排放在实际运行的时候呢还是会非常高的。所以我们管理部门在对车辆进行生产前的定型的一些审核的时候呢，我们也非常关注在整个这个污染物产生以及处理的过程中的这些控制要素呢，这个车是不是能很好的满足在各种条件下各种运行条件下都能够进行很好的控制。除了尾气排放呢，我们汽油车由于它这个使用的汽油具有很好的挥发性，我们也非常关注燃油蒸发的污染物排放。目前呢，在我们中国，在汽车排放的所有的碳氢化合物中，燃油蒸发占比已经达到了1半，所以呢，这也是我们控制的一个重点。那么其实说起来也非常简单，燃油蒸发排放的原因呢，就是这个汽油车上所有跟这个汽油有接触的这个部件，或者说跟汽油蒸汽有接触的这个部件都会产生泄漏，有可能是从接口泄漏的，也有可能是这个管壁它本身是有机物的有机制造的管壁，它跟这个汽油是相容的，它可能产生一些渗漏。那么我们如何处理呢？我们就是要把所有的这些蒸汽呢进行收集，收集之后呢放到这个碳罐里去做处理。这个跟这个固定源的 VOC 的集中收集处理非常像，就是用活性炭处理之后呢，那个排气就得到净化。但是呢，我们这个在车上装的碳罐呢是没有办法进行日常的维护保养的，所以我们有一个自动净化碳罐的这么一个系统，它能够定时的让活性炭得到这个更新再生，使整个碳罐呢始终保持高效的这个净化效率。那么下面给大家介绍一下汽油车的排放控制技术。那么汽油车的排放控制技术呢，主要包括3大类，一类呢就是尾气排放控制系统，一类呢就是燃油蒸发排放控制系统，还有一类呢就是曲轴箱强制通风系统。尾气排放呢，它是包括机内净化和机外净化2大类，我们是这样来进行分类的。那么机内净化主要涉及的呢，就是增压器、电控系统以及发动机的整体设计。那么这个机内净化技术，它是通过改善汽油的燃烧过程， 让源头上产生的污染物就变少。那么机内净化技术除了能够净化这个就使得排气进行净化之外呢，它还有一个重要的作用，就是我们在做节能减碳的工作的时候，那很大一部分工作呢都是在机内净化这一块。那么机外净化呢，主要就指这个排气后处理系统，它重点关注发动机排出的尾气，在这些尾气进入大气之前呢，通过一系列的手段来对这个尾气进行净化。那么对于汽油车来说，非常核心的一个关键就是三元催化转化器。那么为了保证三元催化转化器能够在适宜的条件下工作呢，这个氧传感器呢也是非常关键的。那么到了国六，就是我们国家6阶段之后呢，除了气态污染物的控制，我们又对颗粒物来进行控制，所以就增加了颗粒捕集器。那么机内和机外净化呢，它是一个有机的整体，它们必须要相互配合好，才能达到一个好的净化效果。比如说发动机除了实现自身净化外呢，还需兼顾排气温度的管理，避免温度过高，使得后处理装置产生损害，也要避免温度过低，导致催化器呢没办法正常工作。那么从这个国1到国6阶段呢，我们机内净化技术和机外净化技术呢，都经历了一个长足的发展的过程。从这个图上大家可以看到，这边这个上半部呢指的是机内净化。那么我们的这个燃油系统呢，当然是从国1开始一直到国6开始呢，都是存在的，都是最重要的一个系统。但是它的技术呢是在不断进展的。燃油喷射的压力呢不断提升，燃油的这个雾化呢也逐步的更加均匀。那么对于进气系统来说呢，进气系统的优化，我们是从2阶段开始采用了增压器。那么后面呢，这个增压技术呢就在不断的优化。另外呢，通过设计进气排气气管等等吧，可以让这个燃料和那个进气呢形成非常好的混合，提高燃烧效率。那么燃烧系统呢，主要是在发动机内部做了很多这个革新的技术。那么后处理系统呢，氧传感器三元催化器呢，它是从国1开始就已经采用了，但是一直到国6阶段呢，这个技术原理是没有变，可是呢，技术是在不断的提升，在不断优化的。颗粒捕集器呢，则是从国6阶段开始使用。蒸发的这个燃油蒸发控制系统的核心关键部件就是碳罐，它在这个吸附的时候呢，它是把油箱中的油气，那么吸附到这个它的这个活性炭中，然后呢再排出到大气。那么脱氟指的是当这个发动机正常运行的时候呢，我们会让这个外面新鲜的空气反向的穿过这个碳罐，把碳罐中储存的这些油气呢带走，带到发动机中进行燃烧。曲轴箱通风的方法就是一个很小的装置，几块钱的成本就能够解决。它把这个曲轴箱通大气的口呢，原来是直接通大气，那么现在呢，它是用一个管子和一个这个单向的阀，把这个曲轴箱的排气呢导入到发动机的进气系统里头，进入到发动机进行燃烧，解决了这个排放问题。我们这个表中呢给出了国1到国6轻型汽油车排放技术的升级，以及因为这个排放技术的增量所导致的这个减排的成本。那么国1阶段跟国1前的阶段呢，因为当时呢主要就是国1前的阶段呢，它的这个成本呢是100块钱。那么国1到国2呢，由于采用了这个后处理装置，主要是三元催化器，那么成本呢增加了1200块钱，这是一个比较大的技术跨越。 那么到国3阶段呢，因为这个技术没有太大的跨越，只是对3元催化转化器进行了一些优化，因此成本不高，只有200多块钱。那么国3到国4的时候呢，又有一个比较大的飞跃，到国6呢又增加了1300块钱的这个成本。总体来说呢，这个汽油车升级尽管成本是有所提高的，但是呢，占比在车价中占比不高。对于消费者来说，他们在买车的时候是没有感觉的。汽车厂呢，通过他们一些其他的同步的技术升级，比如说动力性啊、舒适性的升级呢，来把这部分成本就给覆盖掉了。那么柴油车的控制技术跟汽油车比较相近的，就是它们都是包括了机内净化系统和机外净化系统。这张表呢给出了柴油车技术发展的一个过程，包括典型机内净化技术和典型的机外净化技术。这个图呢，请大家会后可以自己看一下，我不在这里做具体的讲解。那么柴油车的后处理技术呢，目前来说包括柴油机的氧化催化型转化器，稀燃的氮氧化物捕捉器，选择性催化还原器、氨陶异补给器以及柴油车颗粒补给器这几种产品。那么柴油车呢，它的后处理系统相对于汽油车来说，大家已经看出来了，它就非常复杂了，因为它不能够同时的进行氧化还原反应，所以呢，都要通过单独的后处理装置来解决。那么不同阶段的这个技术呢，是在一个逐步的复杂和升级的这么一个过程。从价格来说呢，国1的这个升级成本呢是500元，那么国1到国2呢，由于增加了增压器以及优化了内燃机，当时成本是2000。到国3呢，因为电控系统的应用呢，导致了很大的成本，是15000块钱。那么国3到国4呢，国3到国4，由于增加了 SCR 等等技术，当时成本呢是增加了1万块钱。那么国4到国5呢，是因为要进一步降氮氧化物，同时呢还要防止氨泄漏的问题，增加了 ASC， 所以又增加了5000块钱的成本。那么到国6，因为增加了 DPF， 是增加了18000的成本。在用车的检测技术呢，我觉得首先就是这个车辆的周期性年检。目前来看呢，怠速法和自由加速烟度法呢，已经不能满足检测的这个管理的需求，所以我们国内呢都是采用汽油车采用简易工况法，一般呢是稳态工况法来进行检测。这是它的一个系统，它跟实验室的设备呢是形式上是非常相近的，只不过是简化了一些。那么对于柴油车呢，我们采用加载减速法来进行检测。那这个方法呢，欧洲和美国也有在用，但是中国的特点呢，就是我们在这个方法上增加了一个氮氧化物的排放测试要求和限制。主要是控制柴油车的这个确保在用柴油车的这个氮氧化物反应装置呢是正常工作的。遥感法呢，在中国作为一个强制性标准在执行，这在全球呢也是首次。我们目前全国强制执行的遥感标准呢是针对柴油车的烟度的，那么氮氧化物呢是一个筛选的标准。除了遥感法呢，其实很多地方呢还用黑烟抓拍的方法来抓这个黑烟车辆。信息化平台我觉得是我们这几年发展的一个新的创新点，也是我们关注点。我们目前各个地方城市和省都建立了天地车人一体化的多元监控的这么一个体系，那么获取车辆全生命周期的这个核心数据。 车辆的这个核心数据呢，我们主要是依据了重型车国六标准对重型柴油车的远程监控的这个要求来提出的。除了新的这个国六车要安装这个远程监控系统之外呢，地方环保部门也会要求一些这个大的运输企业对他们的在用的重型柴油车安装这个系统。那么信息平台呢，通过整合多元数据形成一车一档，每个车呢从出生到使用过程中，它的这个运行情况、排放控制装置的情况，它所行走的路线、它的油品的使用情况，我们都记录在案。通过这些数据呢，我们能精准的识别关键的污染问题，比如说车辆的使用情况。通过它那个加油情况的信息呢，我们就能知道它是不是去黑加油站，就是非正规的这个加油站进行了加油。那么除了对车辆能进行监管之外呢，也帮助我们去筛查黑加油站的信息。那么我们还可以识别高污染的路段，通过这些信息呢，帮助地方环保部门设置合适的管理措施。另外呢，我们也可以识别这个高污染的时段，帮助地方环保部门精准执法。这是一些平台的一些展示。那么这就是我今天要介绍的主要内容。因为时间的限制呢，我没有把我这个所准备的材料做一个全部的介绍，我还有20多页的这个素材，今天没有讲，但是会后呢，我会给大家提供。谢谢。
好，谢谢您主任您的精彩和详细的这个介绍和分享。其实从您介绍中也可以看到，随着这个机动车控制加强，不仅是车辆本身的排放控制技术在提升，包括管理也在走向精细化和监管的技术也在不断提升的。也再次感谢倪主任的分享。其实王教授和倪主任在电力和交通领域介绍的这些技术呢，我们也编制成了技术手册，上面有更加详实的内容。未来呢会分享给大家，大家也可以在之后这个技术手册中查看到更多的信息。好的。然后在2位专家分享之后呢，我们注意到聊天区和评论区已经有一些积极的问题，然后希望得到回答，所以我们就在正式开始第2个环节之前，先简要将2个问题抛给王教授和倪主任，请2位来分别做一个简要的回答。首先是针对提给王教授的一个疑问。王教授，您现在可以听到吗？
我能听到。
好的。有一位参会者问到说，关于电厂排放标准升级过程中的带来的这种较高的成本，政府有没有支持或者是说提供一些补贴？也问到了说亚开行在京津冀区域的这种投资有没有涵盖其中的一部分？最后呢，就是说这种成本对居民的电价有没有影响？就是在这个问题上，希望能让您就是更加详细的一些答复。
第一个就是大规模的这种的脱硫或者脱销，实际上它并没有政府拿出来补贴，提供的就是电价的支持，也就是说上网电价，每一分就是每1度电它二氧化硫给1分钱，1分5，氮氧化物给1分钱然后呢烟尘如果是比排放标准的要求还严的话，它给2厘钱的这样的补贴，超低排放给1分钱，所以它就没有大范围的这种补贴。但是我为什么讲到大范围？因为个别的电厂可能还能够申请到一部分补贴，但这个呢都是主要的就是小部分了。另外呢，就是对于环保公司，比如说推进脱硫脱销环保公司，在引进技术和设备的时候，它有一些比如说免税的一些支持但最重要的还是环保的电价。第2个问题呢，就是它最后居民的电价是不是升高了？因为在一开始的它主要是补贴到上网电价，也就是说在上网环节给你补贴， 那是否要传导到居民，他要根据当时的情况，有一些呢是过了一段时间，比如说经济的发展各个方面都成熟的时候，然后呢，它终端的电价进行调整，调整的时候，他就会讲到我为什么要调整呢？其中一部分可能是可再生能源的补贴，另一部分就是脱销其他环保电价的增加。因为最终它还是要传导到终端，它只不过是它没有同步的传导，它要根据实际的情况。第三个呢，回答一下，就是包括世界
To answer the third question, the World Bank or ADB, in the initial stage, in support of China's pollutant control equipment, R&D, and other aspects, and some specific projects. And in the early 1990s, the World Bank and in the EIA, and they offered some support. However, large-scale denaturation and desulfurization, the capital needed is really huge. So there is no specific grant or subsidy given to a specific project. So this is the overall situation from China. And thank you, Professor Wang. And also, there is a question to Professor Ni. It's also about the cost. Another question on costs from my side were all of the additional costs between standards passed on to the customers in higher vehicle costs or any subsidy from government to encourage uptake of cleaner vehicles. Professor Ni, can you answer this question? Well, this is a very interesting question. And this is a case-by-case analysis. If it is a family vehicle, like the passenger vehicle, we do not see very strong conflict in increasing the cost because we know the petrol vehicle emission technology is not very expensive. On the other hand, relevant to the sales policy of the OEMs, there is a guiding price for the new vehicles. When they were shipped out of the plant, they were sold at the guiding price. And after 1 to 2 years, and when the vehicles are phased out, the price will be 30% off. Even 30% off, the OEMs still make money. So under that sales strategy, the average citizen in purchasing the vehicle do not feel the price of the vehicle is up. At the same time, you know that in China, we have some policies in the passenger vehicles, for example, early phase out and take Beijing City. And there is some subsidy given to it, and multi-thousand or multiple tens of thousands, and they will feel the sincerity from the government. We get some subsidy from the government for phasing out the vehicles earlier, and every several years, Beijing City and will always update the on-street restrictive policies in some heavy polluted days, and these high emission vehicles will be banned onto the roads. So the consumers, in order to have a convenient traffic, prefer phasing out the old vehicles ahead of schedule. How about commercial vehicles? And some local governments, in order to phase out the old vehicles, offer some subsidies. But some local governments do not have such a physical capability, so they cannot offer the subsidy for phasing out the old vehicles. The central government proposed idea of phasing out these old vehicles. However, to the city level, it is very difficult for them to realize the goals set by them. Of course, there are some problem there. Okay. Thank you, Professor Ni, for your answer. If you have a further question, and you can send your questions into the chat box or on the comments, and afterwards, and we will have another Q&A session to offer you the answers. And with that, we started the second session this afternoon, and that is the technological introduction. Every company has 20 minutes. So please delegate. May you please watch your time. And first of all, we will have 3 delegates from the power sector. Now I'd like to invite Beijing SPC Environment Protection Tech Company. And you may share your screen and turn and also unmute yourself. And please play your slides. We cannot hear you. How about now? Yes? No problem. Hello, everyone. It's my great honor on behalf of my company, Beijing SPC Environment Protection Tech Company, to talk about SPC 3D integrated desulfurization, dust removal, and waste and water saving near zero emission technology. Such a long name. And first of all, I want to talk about our company, situation of our company. And ours is a listed company in Shenzhen city, and its major shareholder is Sichuan Development Holding Company. We are a comprehensive environmental protection service provider, integrating technology, engineering, design, construction, operation service, and capital investment. And we have a lot of technological pipeline. Professor Wang and talked about one typical technology used in China, and it is from our company, one of the earliest pioneering technologies. And you may see from the technical overview from the left hand, at the beginning, we will have the fuel gas treatment technology to water saving and water treatment technology. And we have such a and we have 153 patents, and 63 of them are international patents. And our company, and we have 2 national advanced awards, and one is a clean emission. The other one is clean technology for denitration. And we have the project, the construction, operation, and also intelligent service. And I want to talk about some typical cases. And in our business covered. And let's look at the thermal power plant. And these are very typical ones. And the one is the Topto company, the largest power company in Asia. And that is 8 times 600 megawatt plus 2 times 300 megawatt, which is a very large one, Tokyo power plant. The other one is Xukuang power plant, and that is a very typical plant. And this is a manned wet desulfurization process. The other one is located in Shanxi province. It is called Wuxiang power plant. And it is 2 times 600 megawatts, ultra low emission. The last one is a Fengrun power plant, super clean power plant, and it is a typical one in China. And we have a clean technology in process. Let's look at SPC's main business, such as thermal power, flue gas treatment, non-power plant, and overseas business, industrial wastewater. If we look at the thermal power, for many years, and we rank top 3 in China for many years, no matter EPC, contracted construction, or the third-party management and operation, and we rank top 3 in this industry. Well, let's look at the left hand. Professor Wang already mentioned the first. It is the first set of desulfurization device for large thermal power plant with independent intellectual property rights in China. Unity capacity 200 megawatts, emission index sulfur dioxide less than 200, dust less than 30. And the other one is 10 years later, super low emission flue gas unit of 2 times 1050 megawatts unit in Shenhua, Wanzhou power plant, and emission sulfur dioxide less than 17, dust less than 5. On the right hand, built in 2018. It is in Inner Mongolia, Xinning-Guole region, and this is a flue gas ultra low plus water recovery, emission index sulfur dioxide less than 10, dust less than 3. So that is one step further than ultra low. It's almost zero emission. So talking about our technology, and very briefly, let's look at the technology, and we have on the left hand, and when we see we have the temperature economizer, and we have a wet desulfurization. The goal is to realize ultra low emission on the upper hand of it, and that is near zero emission. At the same time, the other function, after desulfurization and dust removal, the flue gas temperature is managed under 53 degrees and enters the cooling and the condensation tower. At the same time, we can have second time removal of the pollutants to make it near zero. And we not only remove the sulfur dioxide and the dust, and also the residue HC, FC, and other pollutants and aerosol, and all these chemicals should be removed so that this flue gas is near zero emission. And let's look at the desulfurization technology. And from the boiler, we have the gas denitration and also the wet technology. And it is similar to the tower we see now. There are 3 components of it. The first one, the bottom-up revolving turbulator FGD device, and there is a turbulator FGD device, and Professor Wang already mentioned this. The other one is a high-efficiency spray device. On top of it is the tube bundled demister. The 3 technology can realize the one single tower near zero emission. The advantage of it is very evident. Single tower realize near zero emission. And also we can have a very low concentration of sulfur discharge, and with the condition, with the temperature at a very low level. And in terms of with those high sulfur tower, this technology, and in the wet technology, it has more advantage, and operational cost and maintenance cost is lower. And in the retrofit project, the retrofit cycle is quite short. And let's look at revolving turbulator desulfurization and dust removal device. This is how it looks like within the tower, exactly like the picture I show here. It's very easy, and we have a strong mass transfer, and there is a mix of the gas and the liquid, and a very good mix of them that is solid, not removable, static, and it is a mix together. And how good it is, I want to show you this. This is the first one. And let's look at without a turbulator. And on the right hand is with turbulator. On the left hand, without. And on the right hand, we have the turbulator. And you can see the difference.
So we can see that the uniformity is quite good. So when we look at the mixing device, on the left, it is from the up view. And we can see this is the contacting between the liquid and the gas. So you can see here there are some small droplets. On the side view, we can see that there are the gases and they are mixed into this liquid. And the mixing effect is getting much more improved. And we also can see this is the uniformity improvement. And we can draw a conclusion from this atmosphere that in the mixing system, it is the mixing effect is closely related to the flow rate of the smoke. And here we can see this is the spring layer. It is a unique device, and we have the patented nozzle and the layout. This is the high efficiency and energy saving spring layer. And it can improve the secondary efficiency of the mixing. And the contact area is also getting improved. And with this technology, we see the effect. It means the desaturation efficiency is getting comprehensively improved. In the turbulator, with the flow rate is getting higher, we see that the efficiency is kept at a high level, and this relies on the spray layer. With these two devices work together, we can see the green curve. This pink one is the spray layer, and our target is the green one, that is of a high combination result. So here we can see this is the tube bundle type test, dust and mist removal. So we can see this is the flow gas passes through the cyclone separator to generate a high-speed centrifugal motion. And these droplets will be absorbed into this film. And we can realize this a very good absorption result. For the ultra-low emission reduction, this is a standard device for almost all the equipments. We can have a look at the efficiency. It is more than 95% when the particle is less than 2.5 micrometers. And this is at the intake. So you can see the spread of the particle. And this is the size distribution at the outlet. So why this difference is caused? So we can see this is the particle size distribution. On this form, it shows that from 1 mu to 4.4 mu is in this red box. It is the total volume in the intake. And in the outlet, it is from 0.5 to 2.5 mu. And for the intake, it is with smaller particles. It is the soluble salt in the intake. And at the outlet, after the treatment, there are some new types of compound particles formed in the reaction. So this is the SPC 3D technology, and it is mainly for the smoke desulfurization. The intake is 8.67 mu. For the pH value, it is about 5.6. it is with a high sulfur content. The volume of liquid is also getting higher. From this graph, we can see the efficiency is quite high. And here I also want to introduce to you the water recovery, because in this treatment, we also need to look at the efficiency of the water utilization. So we will use a heat exchange and use the cooling water. And this is for the saturated net flow gas. And then we use the cooling circulation water to lower the temperature. When the water goes into the cooler, we will keep the temperature down, and the recovery can also be realized when the condense is happening. So this project is finished in 2019, and we have finished the commissioning, and it has been run for 168 hours in this commissioning. So you can see this is the water saving that is 90 tons per hour. The flue gas volume is about 233,000 cubic meters per hour. And this is the absorber slurry tank, the turbulenter, the spray level, and the tube bundle, and also the gas lift plate, and also the spray level. To improve the heat exchange efficiency, it also has another spray level. So this spray level sprays the water, and then we have another level of the tube bundle demister. So on the right bottom, we will see the actual project. This is the project case. The diameter is 18.2 meters, and the desulfurization layers diameter is 15.2 meters. The total height is 56.5 meters. And you can see this is the valve multiplied with 10,000 cubic meters per hour. That is for the throughput. So in the testing, we also have seen the emission is 2.6 milligrams per cubic meter. And also we see the efficiency is shown here. With the water recovery, if the water recovery is on, that is the blue line. With the unit getting off, it is the orange line. So you can see the difference is quite significant. So with the water recovery, the efficiency is doubled compared with when the water recovery is off.
Recording stopped.
And we also
Recording
can see
in progress.
this is the evaluation unit. So we can see the different load. For the efficiency, it is about 3. And for the water recovery, with the different water conditions, the highest recovery is about 121 tons. And for the water quality, it can satisfy the requirement of the industrial water usage quality. The pH is lower, that is a more acid content. And you can see here, the TDS is high, but for the magnesium and for the calcium, the content is lower. With the operation, we have the constant corrections on the water treatment result. In the whole process, we also can have a look at the economy. For the, if at the similar, the average level of the electricity price, the 1 ton of a water reagent, the cost is about 1.6 RMB. And the load is from 1.1 kilowatts to 1.28 kilowatts. This is the operation result. And this is for the SO2 emission concentration. Okay, this is the long-term operation record for last year. We can see clearly here that this is the load and the water recovery. So you can see the high correlation among the curves. With a high load, the impact on the water recovery is here, and the water supply is high. So here for the ambient temperature, we haven't got the water. So the ambient temperature is less than 40 Celsius. So we stopped the water recovery. So this technology in the operation, it is more suitable to the places with the demand on the ultra low desulfurization, and it is sensitive to the water resources. If in those places, this equipment is more friendly. Okay, this is my content. Please feel free to contact me. So you can see this is also posted on the ADB website. And if you are interested in this technology, you also can look at our website to get the contact of SPC. Okay, our next speaker is from the JNG, and they will talk about the ammonia-based desulfurization technology. So let's welcome our presenter from Jiangsu New Century, Jiangnan Environmental Protection Corporation.
您可以打开您的麦克风。能看到吧？可以看到，您可以
Okay. And now please use the full screen.
好，各位女士、先生们，能听到吧？
可以听到，很清楚。
Ladies and gentlemen, dear experts, dear representatives, good afternoon. On behalf of the Jiangnan Environmental Protection, I hope to share with you our EADS technology and the application in the desulfurization. So I will talk about three major parts. The first is the company's brief introduction. For the JNG China, it provides the metallurgical and steel mill for the pollution treatment and the commission and the carbon emission reductions treatment. We provide services in a comprehensive way to the enterprises. The company was established 25 years ago, and we focus on the pollution control and improve the human living conditions. We have the Class A design qualification for the chemical engineering, and we can do the APC and also the GNEP. And we also have the franchise and the contract operation qualifications. And we also participate in the drafting of China's ammonia-based desulfurization standard formulation. We have 117 patents, among them 56 are invention patents, and we have 11 groups of international patents, and altogether 159 patents. All of them are invention. Before 2004, we used the first generation technology, and now we have come to the fifth generation technology. So currently, we look at the high SO2, high water content, and the high fluctuation. So with those, we can do the ultra-low desulfurization, and the 99% efficiency for the sulfur is realized. For the recovery of the ammonia, it is over 99%, and the total is below 5 milligrams for the dust. For the EAD, we have 150 contracts signed, and we also have over 400 set of absorbers around China. It covers the chemical, electricity, steel, SRU, pharmaceutical, and other sectors. For the EAD, we have a market share of over 80%, and for the market share of the large projects in China, ours is 90%. So for the EADS, ammonia is a very active absorber. So the absorption of the SO2 will go into the ammonia sulfur fertilizer. So this is the process principles. And after the ammonia sulfate solution is concentrated, crystallized, it will be dried into the ammonium sulfate fertilizer, and we don't have the waste produced. For the EADS, it covers three major fields, including the coal-fired power plant and the sulfur-containing tail gas in the petroleum, and also the carbon capture. So currently, the advantage of the EADS technology includes it can realize the recycling of the waste resources and meet the requirement of the circulating economy. And also, with the final product, it is put into the ammonium sulfate fertilizer, and we don't have the pollution and the waste discharge. We do not have the secondary pollution, and for the desulfurization agent, we don't have the CO2 emission for that. We also have very good efficiency and economic benefits. We can see for the low absorption cycle quantity and also the low operation power consumption, for each ton of ammonia, we can produce 3.8 tons of fertilizer, and it can help to get the high value-added fertilizer. And we also have the strong adaptability to the sulfur content in coal. And we can see the EADS, the efficiency is getting higher, and it can be applied when the sulfur content in coal is between 0.3 to 8% or even higher. And for our facilities, since the ammonia sulfate, it is soluble into water, so it has no blockage efficiency, blockage damage. Also, the facility is quite stable. And China has a large demand of the chemical fertilizer. So for our GNET's integrated ammonia-based desulfurization and decarbonization technology, we can have the resource utilization of the tail gas containing sulfur and carbon, and the ammonia-based desulfurization can reserve room for the ammonia decarbonization. And if I compare with the limestone process, we can see that in our investment and our operation, the cost is quite advantageous compared with the limestone process. This is the traditional limestone. And with our EADS, if we compare this with the limestone, we can see this system is convenient for the retrofitting. And for the limestone system, it will be turned into the sulfate ammonia system. And also, we use the slurry, we use the liquid ammonia to remove the slurry system. So we use these case studies to show the efficiency, and we can see that for the 3 units, the annual saving is about 25 million RMB per year. In the retrofitting, the cost is also quite low. The investment is about 42 million. For the 3 units, the ROI can be less than 3 years. The effect of the social benefits is also getting quite well. We have no CO2 emission, no discharge of the subsidies. So for the future of the technology, with the ammonia, it is produced with PV units. The power price is 0.2 yuan kilowatt hours, and the cost of the green ammonia is about 3,000 RMB per ton. In the future, it will be further reduced, it will be much lower than the petrochemical process. So this will be beneficial to the EADS widespread because we have a better environmental protection, economic benefits, and social benefits. We're also working with the Hydrogen Corporation, like the strategic cooperation with China Hydrogen Energy, and with the electrolysis to produce the green hydrogen and the green ammonia throughout the country, and promote the integrated technology for the ammonia-based desulfurization and decarbonization in the power plants. With the EADS widespread, it can accelerate the ammonia industry to be transformed into a green industry. And we also can significantly reduce the carbon emission for the synthetic ammonia industry. And we also can solve the fluctuation and abandonment clean energy for the further reduction of the cost. And at present, there are hundreds of clean energy companies with similar size in China. This cooperation model can be duplicated and popularized in the future development.
Low-cost green ammonia first lays a solid foundation. And we know that with the low-cost green ammonia development, and this technology will give you higher environmental benefits and economic benefits. And with this integrated technology, we are able to realize the carbon capture, and we can have a clean utilization of these resources. And integrated ammonia-based desulfurization and decarbonization technology is low in investment and operation cost. The byproduct is ammonium sulfate and ammonium bicarbonate fertilizers with high added value. It not only realizes energy conservation and emission reduction, but also realizes the resources utilization of sulfur and carbon so as to promote the zero carbonization development of chemical fertilizer industry. And at present, the green ammonia development is very fast. And we have this ammonia desulfurization, and we have ammonia decarbonization, and we will have the green ammonium sulfate and ammonium bicarbonate fertilizer. We are able to realize a zero carbon industry. At present, ammonia desulfurization has been used in tail gas treatment in electric power, refining, chemical industry, steel, and other industries. Combined with integrated ammonia-based desulfurization and decarbonization technology to treat the rest sulfur dioxide, carbon dioxide, it can promote zero carbon development in multiple industries. And this is our overall industrial chain. And with the wind power, with PV, and we are able to have the production of green hydrogen from electrolytic, production of green ammonia from green hydrogen, zero carbon power plant, and we can actively decarbonize and desulfurize. And finally, we will have low cost and zero carbon fertilizer. And we will use it in the zero carbon fertilizer plant factory to grow vegetables and grain. And that's the end of my presentation. And if you need to communicate with me, feel free to contact us. Thank you very much. Thank you, Madam Qin, for your wonderful introduction on the desulfurization technology. And now we move to another company introduction on its technology. We are going to have SPIC Yuanda Environmental Protection, who is going to talk about this carbon reduction technology and how carbon is utilized. Our colleague from Yuanda, can you share your screen? Please full screen and unmute yourself. Thank you. Distinguished ladies and gentlemen, good afternoon. I'm from SPIC, and my name is Deng Wuchao. And today I'm going to talk about pollutants, ultra-low emission technology, and CCUS technology. There are 3 items on the agenda. First of all, our company briefing. Secondly, boiling type froze integrated FGD and the dust technology for coal-fired flue gas. Thirdly, flue gas CCUS technology. Well, some words about our company. And SPIC is an integrated and comprehensive energy group enterprise with power generation as the core business. It is one of the 5 major power generation groups in China and the world's largest photovoltaic power generation company, ranking 293rd among the world's top 500 enterprises in 2021. By 2021, the company's total installed power capacity is 195 million kilowatts. Photovoltaic power generation installed capacity, new energy power generation installed capacity, renewable energy power generation installed capacity ranked first in the world. Renewable energy power generation installed capacity of 120 million kilowatts, accounting for more than 61.53%. It has a total production capacity of 84.3 million tons and an electrolytic aluminum production capacity of 2.45 million tons. And that is the overall introduction of SPIC. And Yuanda Environmental Protection Company is the only environmental protection industry platform under SPIC. Leading enterprise of air pollution control, catalyst manufacturing extra in China. National business distribution, 30 provinces, cities, and autonomous regions, more than 600 EPC projects of FGD, DeNOx, and the dust removal, international business distribution, 8 countries, including India, Turkey, and Indonesia. We are a comprehensive environment service supplier, covering the following business, in totally 8 of them. They are air pollution control, water treatment, soil remediation, supply of clean energy, solid waste treatment, smart energy, equipment manufacturing, big data, and smart city. Totally 8 sectors within our business scope. And you can see that we have the following awards, such as National Innovative Center, National Local Joint Engineering Research Center, National High-Tech Enterprises, National Enterprise Technology Center, Academician Expert Station, Postdoctoral Program, and all these are the titles given to us. And also, we have the largest raw flue gas cleaning experimental base in China, internationally recognized catalyst performance inspection center, as well as a 10,000-ton level carbon dioxide capture pilot plant. Industrial contributions, the only national training base approved by MOST in China for coal-fired PP, sulfur dioxide emission supervision, international training workshop for coal-fired flue gas cleaning technologies. Let's look at the second part of the presentation, boiling type of froze integrated FGD and dust technology for coal-fired flue gas. Coal-fired flue gas boiling foam desulfurization and dust removal integrated technology. It has the advantage of high efficiency, low investment, low energy consumption, strong adaptability, high stability, short construction period, and no need for additional sites. BFI is suitable for flue gas pollution control of various coal-fired power plants. The technology consists of 3 parts: boiling foam mass transfer, fine spraying, and high efficiency demisting. And with the time involved, the emission limits is getting more stringent. And after 2014, we start to realize a ultra low emission and 5 milligram for the PM, and also sulfur dioxide 35 and smoke 5, NOx 50. And this will be, and those which below ultra low requirement needs to be technologically upgraded so that it can meet the needs of ultra low emission with high efficiency and low investment and higher reliability. And while we are discussing our technology, and we need to consider all these issues in order to make ourselves live up to the expectation. And these are our technical parameters. Desulfurization, the rate can reach 99.9%. Absorption tower inlet, sulfur dioxide more than 10,000. And let's look at, and we can see a 35 program, and we have the NOx is around 1,000 milligram, and also the outlet is less than 50 milligram, and also the efficiency is more than 90% for the NOx, and outlet NOx is less than 50 milligram, and the dust removal efficiency more than 80%, absorption tower inlet dust less than 30 milligram, outlet dust less than 5 milligram, the mist outlet droplets less than 30 milligram. And this is the integrated desulfurization and dust removal technology and how it is constructed. And this is the mass transfer, and we have the accurated spray, we have the fine spraying banks, and deep the dust. Technological comparison, and except China, the mainstream technology is wet electrostatic precipitator technology. Yuanda BFI technology can realize the sulfur dioxide less than 35 milligram and the dust less than 5 milligram. Comparing with the wet ESP ultra-low emission technology, the initial investment can be saved by more than 50%, and the operational and the maintenance cost can be reduced by 10%, reducing the international advanced level. And this is the technological process. And we have a parameter of the technology in comparison. And also, this is the intellectual property rights. Yongda currently has 344 valid patents, including 124 invention patents and 220 utility models, presided over and participated in the formulation and the revision of 42 national and industry standards and registered 28 software copyrights, 1 international patent. And let's look at a typical case in place. And this is the Shanghai Caojing 1,000 megawatt flue gas ultra-low emission desulfurization and capacity expansion renovation project adopts Yuanda's ultra-low emission technology of environmental protection, desulfurization, and dust removal. It is a typical demonstration project of SPIC Group million unit ultra-low emission. The actual operation data shows that the sulfur dioxide concentration at the inlet of the absorption tower is 2,770 milligram. Sulfur dioxide concentration at the outlet 12.23 milligram, and the desulfurization efficiency is 99.5%. The smoke concentration at the outlet is 3.04 milligram. The dust removal efficiency is 87.3%. The sulfur dioxide and the soot emission values both meet national environmental protection requirements for gas turbine emission standards and reach ultra-low emission standards. On the right hand are examples of other typical projects. And let's look at the application in China. Yongda Environmental Protection has signed contracts for more than 600 desulfurization, denitrification, and dust removal EPC projects, and a contract volume of nearly 27 billion yuan. It has built a number of landmark power environmental protection projects, such as China's first million unit denitrification project, China's first million unit desulfurization project, and China's first million unit ultra-low emission project. It has won one Luban Award for China construction engineering, 2 gold awards for national quality projects, 8 silver awards, and 25 other awards. On the right hand, you see the pictures of the projects. They are China's first million unit desulfurization project, Zhejiang Yuhuan Power Plant. And the other one was completed in 2008 in Shanghai, China's first million unit denitrification project. It used our technology, that is Nanjing Jingling Power Plant, China's first million unit ultra-clean renovation project. And the last one is China's first integrated smoke tower desulfurization project, the Beijing Thermal Power Plant. How about our international application? In India, Turkey, Pakistan, Morocco, and other countries, 10 environmental protection projects are conducted. The India Jiajia 2 × 660 megawatts supercritical coal-fired unit flue gas desulfurization project is the first full flue gas desulfurization project in India. The Turkey Atlas 2 × 600 million watts desulfurization project has been in continuous operation for more than 15,000 hours since it was put into operation. And this project has won the 2012 Outstanding Infrastructure Award in India. Now I want to talk about the CCUS technology. And let's look at flue gas CCUS technology. CCUS is an industrial process to separate and purify carbon dioxide from the flue gas of coal combustion or gas combustion for further utilization and the storage of carbon dioxide and to realize carbon dioxide emission reduction. It is a critical technology for China and the world to realize to reduce carbon dioxide emission, to ensure energy security. And this is a technology what we call is pollution first, treatment second. After generating a lot of carbon dioxide by CCUS, we're able to capture the carbon dioxide and to better utilize the fossil fuel. And this is a very important technology to realize carbon emission peak and carbon neutrality. And the CCUS, let's look at the flue gas CCUS technology, and we have carbon dioxide capture, and then to store it, to transport it, and this is the process. At the present, according to the World Energy Report, BP 2020, globally, $100 million GDP, that is 39,000 ton carbon dioxide emission, China is around 69,000 ton emission per 100 million US GDP, which is above the world average. And let's look at the carbon dioxide capture research. In 2007, initial research and experiment were made. In September 28, building the first 10,000 ton level CCP in China. On January 20, 2010, CCP industrial operation started. In 2011, we completed relevant research and experiment. First of all, the generation of degradable plastics, and we have a very good carrying in 2012 carrying out FS on carbon dioxide geological storage in Chongqing region, undertaking World Bank CCUS capability building project, FS on carbon dioxide geological storage with capacity of 100,000 ton and 1 million ton per annum.
So the UK-China Prosperity Strategy Fund project was carried out, and we have done the investigation on the SO2 centralized emission sources in Sichuan Basin. And in 2018, we have done the studies on the carbon-rich agriculture and to improve the quality and output of the crops. In Yuanda, we also have built the first 10,000 tons level CCP in China constructed and awarded with the China Electric Power Science second prize and also the Science Advanced first prize of SPIC. The technology we use for the CCP is the chemical absorption process. We use the amine compound solution as absorbent, and it is recyclable. For the fuel gas, its flow rate is 8,400 cubic meters per hour. CO2 capture volume, that is 10,000 tons per year. The final product purity is over 99.5%. And the CO2 capture rate is also over 95%. So for the test, we have the absorbent performance and reducing capture energy structure, and we have the flue gas desulfurization and absorption and regeneration. We also have the compression and the drying, and also the cooling liquidation. The related studies and the research have been carried out, and we are now looking at the performance of the absorbent, and also the efficiency is getting further promoted, which means less energy used. So we have been leading 5 national industrial standards for the CO2 emission reduction. And also we have the engineering and the construction capability for 1 million tons per annum CCP. The third part is for the CO2 utilization and the storage. So first, it is for the carbon rich, and the second is welding protection. We also have the geological utilization and the storage, the minorized utilization, and the stabilizing carbon with the microalgae, and the CO2 and hydrogen into the methanol. In the research and the development, we also can see that the carbon rich, the welding, and the geological dust removal and the mineralized, the utilization is limited. So later, we started the methanol production, that is to have the hydrogen added into the carbon dioxide. So from the coal to methanol, it has a byproduct, that is 1.3 tons of CO2. If we use the CO2 plus the hydrogen process, it can consume the CO2 produced. And the total CO2 emission can be around 4.6 tons for the production of each ton of methanol. The utilization efficiency is getting higher, and the potential is also getting higher. And we believe that this will be a major direction for the utilization of the CO2 captured. Okay, this is my presentation. Thank you very much. And this is our contact. If you are interested, please feel free to get out and reach me. Thank you very much. Okay, in the power generation, we have shared the experiences of 3 enterprises. So if you are interested, and if you have further questions, please type in your questions in our chatting box. And we have seen some of the questions coming out. Please wait for a while, and we will have the further introduction about the transportation. And after that, we will go into the Q&A session. So first, let's welcome a engine producer representative, Guangxi Yuchai. We will have Director Wang Hui from the Guangxi Yuchai Technology Academy, and he will talk about the diesel engine technologies and the emission reduction. So, please start from the first page. Dear colleagues, ladies and gentlemen, I would like to share with you the emission control technology and adaptive development of the China 4 and 5 commercial vehicle diesel engines. I will talk about the 4 major parts. The first is the analysis on the technical routes for China 4 and 5 on the commercial vehicle. And the second is the determination of the technology route and the determination of the China 4 and China 5 technology route and the development of the adaptive technology for the commercial diesel engines. So if you look at the trend, based on the requirement of the regulations and based on the China 3, we have seen 2 routes, and one is SCR, another is EGR. So based on the China 3, if we look at the EGR, it can help to reduce the NOx, but it will have an increase on the particles. And we will also need the DPF to help with the particle capture. And we have another route that is SCR, and it can reduce the NOx. With the SCR, we can satisfy the requirement for China 4 and China 5. So for the China 4, the technology route is SCR and EGR. If we look deeper into these 2 technologies, SCR is more suitable for the light duty, and EGR, DOC, POC are suitable for the light duty. And also the EGR plus the DPF and the DOC. So for each route, we have done the studies. And for China 5, since the requirement is also getting more stringent, we see that the route is SCR, and another is EGR, DOC, and the DPF combined. These are the 2 major choices. And the factors affecting the technology route selection in the China 4 and China 5 includes the fuel economy and the condition of use, the sensitivity and durability of the fuel, and the engine oil quality, and also the requirement on the urine, the impact of the engine development, designing technologies, and also the impact on the durability. And the 4th is the vehicle emission under the real-world driving conditions. And the 5th is the purchase cost and the customer cost for the operation. So these are the major factors for the selection of the China 4 and China 5. So for the China 4 and the emission control, it has requirement on the engines. For the China 4, so we see that it needs to reduce the particles. And it has 3 ways: in-engine purification, and the in-engine plus the out-engine as a major, and another is with the out-engine as a major. And for the NOx reduction, we have several routes. The first is SCR, another is EGR. And for the requirement of on the engines, so we can see the different route has different requirement. The SCR requires the optimization of the combustion system and the optimization of the structural design. We need a simplified upgrading of the design to satisfy the need. And for the reduction of the emission, we need a common rail and the single pump, and the pressure is not required to be very high. For the EGR, it has requirement on the higher level, like the combustion engine optimization and the improvement of the structure design, like the pressure resistant, the anti-wear capability, and the higher quality engine oil, and optimized cooling system design. For the out of engine EGR, we have the similarly high-level design optimization on the engine itself. We also need the more complicated controlling strategy and also the calibration development. For the fuel system, for the EGR, it will need the controlling on the particles. So we need to have the common fuel injection system, and it needs to have an improve on the injection pressure. For the SCR in the China 4, so we see that if we use the SCR technology, based on China 3, when we upgrade to the 4 or 5, we can use the same platform and no direct conflict between the decreasing emissions and the reduction of the fuel consumption. SCR catalyst in most reliable system in the exhaust after-treatment system, and particularly in China 4, we use the vanadium-based fuel. It is not so sensitive to the quality of the fuel. And for the NO2, it is more toxic. And the proportion of the emission of the NO2 is lower. It has no additional burden on the vehicle's cooling system, and it has no special requirement on the engine oil quality. So this is the data we have got based on the Euro 3. We use SCR. After using SCR in the China 4, we can see the emission reduction. So we can see the previous engine's emission is reduced, and with the SCR, we also can see an efficient improvement. And in the Euro 4, with EGR, it has a higher consumption. We also have studied the sensitivities on the fuel. For the China 4, if the sulfur content is higher, so we see that for the China 3 and China 4, the diesel specification, we see that for the China 3, the sulfur content is at about 350 ppm, and the China 4, it is 50 ppm. So in 2017, we can see in the nationwide, we have seen the supply of the 50 ppm diesel. But before that, the high sulfur content fuel was largely used. And in the China 4, we also look at the DOC and the EGR combined. So we can see the EGRE need to be combined with the after treatment and the DPC. We see the nitrogen dioxide in this temperature range from 250 to 350, it can have the highly efficient reaction between the carbon and the NO2. So the product is the CO2 and the carbon particles is largely reduced. And for the EGR with a high sulfur content, it can realize the oxidation catalyst failure. In the EGR, it also will have the risk on the corrosion and the wear of the components in the cylinder. On the other hand, it has the higher requirement on the cooling technology. If the EGR rate is getting higher, the cooling capacity should be higher as well. And this is a burden on the engine system. So for the China 4, with the EGR rate 18%, and in China 5, for the similar condition, the rate should be improved to 24%. For the cooling, in China 4, it has 11.5 kilowatts for the EGR cooling, and for the China 5, this is 15.7 kilowatts. For the sensitivity of the fuel, after using the EGR, we see that this is an article from SAE. For the same engine, with EGR and without EGR, we look at the wearing on the cylinder liner and the piston, and we can see the piston ring. So we can see with the non-EGR, there is without the cooling, it has a higher damage and wearing. So this will cause a higher risk. And this is for the NO2. NO2 is a toxic emission. Although we use the carbon and the NO2 and realize that the reaction, it can help to reduce the carbon emission, but it will have the exhaust gas increase. So in the China 4, in the domestic regulations, we have already seen that. In the certification, we require that the ESC with the weighted NO2 emission, it should be less than 0.75 grams per kilowatt hours. This is a convention limit in the industry. With the oxidation improved, we should look at the NO2 emission and try to solve this issue. And for the third one, that is for the China 5 technology, with the EGR and SER, we have compared the two in the China 5. We have got the basic knowledge. In the China 5, we see these advantages more significantly. It has a lower NOx limit, and the emission standard makes the development and application of EGR more difficult. Fuel economy could be significantly improved compared with using EGR technology, and with the China 5 using the SER technology can continue the R&D achievements for the China 4. And the customer have accumulated relatively mature SER application experiences. And this is a good preparation for the SER in China 5. On the right, we have a form that is for the EGR and SER, and we can see the China 5's installation of the facilities. So for the EGR, it's not on the engine. So we see the pressure and the strength for the engine cylinder is getting higher. The technology is more complicated. It is difficult to have the harmonized performance of the emission control. The sensitivity on the fuel is also getting higher. So for the SCR, if you look at the China 5, we also see the difficulties in the development. The most significant application challenge is that the urban vehicles has a quite a fluctuative performance, and the load for the buses. We see the buses in China mainly use the new energy, but before we move to the electricity, the conditions on the buses are quite complicated. We also see the lower fuel consumption requirement among the users. We also see the stage 3 at the time, the fuel consumption requirement is also quite high. And we see the lower NOx emit, which means that we need a higher converting efficiency for the SCR. In the China 4, we only require 70%, but in China 5, we require 80% and above. It means we need new technology and the new applications. So this is the work we have done, like the optimization of the exhaust after treatment system. We have the optimization of the catalyst formulation, especially for the low temperature converting efficiency. We can see from this graph that the previous catalyst, the SCR efficiency in the low temperature is quite low, but with the catalyst optimization, and we have improved the converting efficiency. And also the reaction speed is also getting higher. And we have the increase on the catalyst volume, and efficiency can be kept over 80%. So this is the SCR in Yuchai. We have our roadmap for the China 4 and China 5.
And this is the maximum one for the on-vehicle engine. This is the model. At the same time, we actively export and utilize technology in our export models, and we have the first OBD1 certification. And also in July, and Yuchai Diesel has an OBD2 verification for Euro 5, so that we can have very good foundation to export to other countries. Lastly, it is about the approval certificate for the EC type. And in China, the driving conditions are very complicated. For example, there are many compatible vehicles, and we have a non-standardized system layouts. Just now I mentioned urban vehicles such as city buses having low speed and low exhaust temperature. The result is that the temperature is low, and at the time the diesel was the national 3 and 350 level. The first thing we want to do is to have a standardized system. It is a big challenge. And here, there is one typical example how the pipeline, exhaust piping is designed. And that is narrowing down here and widening out over there, so that the distribution and the reflow of it is quite good, and we can have higher efficiency. By our simulation and structural optimization, we successfully solve these issues. The other thing is the urban transportation, which was mentioned by me. The exhaust temperature is quite low, and in the regulated area, and most of the working conditions are out of the regulated areas, and we have a low exhaust area and a non-standard area, and we need to have the conversion efficiency in the non-regulatory control area improved, and this is ETC and WHTC. And we really need to improve the efficiency of the post-treatment, especially the low temperature. In the National 4 and the National 5, and we have ammonia storage. And with the ammonia storage development, the low temperature conversion rate is quite high. At the same time, in terms of non-regulatory emission, it is under very good control. On one hand, we want to enhance the efficiency of the catalyst, and we have the heat management to have a higher HCR efficiency. is relevant to the exhaust gas temperature. So in National 5, we have the throttle control technology so that the exhaust temperature is higher. So you can see the overlapping of the two curves and how the temperature looks like with and without the throttle. And we can have a higher efficiency of the SCR technology. YC Diesel Company has a research of the impact of diesel sulfur content on SCR durability engine rig test, and we adopted the data of 1,000 hours. The durability of the engine, generally speaking, is up to 10,000 hours. And 10,000 hours durability, even though the sulfur is 2,000 ppm, by strategy number 4 and number 8 and number B, and we are able to ensure that SCR efficiency is high enough. On road, we find 2 vehicles for the road testing concentrated in the Guangxi province as well as Guangdong province. By the test, we further confirm the fuel adaptability test on the real road driving conditions. 3 12-meter highway buses with an average mileage of more than 33,000 kilometers. The sulfur content of diesel used in vehicle number 1 and 2 from Zhencheng to Shunde in Guangzhou was 350 ppm. For vehicle number 3 from Guangzhou to Liuzhou, sulfur content of 350 ppm and 2,000 ppm were closed. And let's look at we get a standard sensor, and we try to benchmark A and B sensors against the standardized one. And we find out the operational model of the sensors on board is quite good. And all these are accumulated data. The unit is gram per kilogram because at the time there was no standard available for us to make comparison. So we carry out the experiment based on the durability as well as the trend of changes. And after 330,000 kilograms, and the NOx emission is quite stabilized. And this is a quite a good adaptive technology result. And we try to summarize the content. SCR technical route is the best choice for China 4 and 5 commercial vehicle diesel engines. Even though SCR is good for the emission reduction, however, we need to innovate and targeted development so that we can ensure that high sulfur fuel will not be an obstacle to SCR application. China's emission regulations have been innovated according to the actual road conditions in China. The introduction of the WHTC cycle in the China 5-stage for urban vehicles is in line with China's actual situation. And we need to have a more completed and perfected technology suitable for the regulation. With that, I finish my presentation. Thank you. Thank you, Mr. Wang, for your wonderful introduction. And in your presentation, you talked about technological roadmap and the actual considerations behind every technology. And you may finish your screen sharing. The speakers shared with us a lot of information. Probably you need some short break. We propose we can have a 3-minute break, and you can stretch yourself. And also you may browse our technology fair, and this is the website, and you can check. How about we come back Beijing time, 4:03, Philippine time, 4:03 after 3 minutes, and we will have 2 presentations on the vehicle companies. Thank Okay, thank you very much. And after talking about the engine emission treatment technology, and also we have Wuxi Weifu Environmental Catalyst Company, Mr. Wang Gang, and a very important role played by the catalyst in the treatment technology. Now, I'd like to give the floor to Mr. Wang. Would you please share your screen? Please unmute yourself. We cannot hear you. Yes, we can hear. Distinguished guests, ladies and gentlemen, now I want to talk about Wuxi Weifu Environmental Catalyst Company. Some of the research experience in the catalyst. There are 4 parts in my presentation. First of all, company profile. And we were established in the year of 2004. In 06 and 09, we established Automobile Exhaust Purification Engineering Technology Research Center and Academician Workstation. And in 2011, we built a key lab on the emission control. And in 2016, we have plant and capacity expansion. On the lower right hand, and you can see the new plant on Huashan, number 16. And in 2019, we had R&D technical center expansion. And apart from the mobile sources, the fixed or static source is also covered by us. In 2020, we built Shanghai Yitai Precious Metal Material Company Limited and Nantong Zhouwei High Tech Company Limited. And this is the main product family. And diesel engine, petrol engine, and the static sources. In terms of new energy development, we have some material, the battery material. The main products, TWC plus CGTF is compliant to motorcycles, gasoline vehicles emission control. In a stoichiometric combustion condition, 95% of carbon monoxide, hydrocarbon, and NOx can be eliminated simultaneously. PM will be captured in a combined GPF. As a result, the emission of motorbike will meet Euro 4 and beyond regulations. The emission of gasoline vehicles will meet Euro 5 requirements. At present, in terms of Euro 6 and National 5, we have TWC plus TWC or TWC plus GPF. And in terms of motorcycles, and we have TWC for both passenger vehicles as well as the motorbikes. And we have in terms of N1 type, let's look at the technological roadmap is quite different. And in Euro 4 light duty, we just use DOC. But in N2 and N3, we need to have SCR. And the Euro 5 light duty, DOC plus DPF. And the National 2, National 3, we use DOC plus SCR or SCR only. In Euro 6, there is a stringent requirement in terms of NOx emission and the sulfur dioxide emission. So light duty, we have a DOC plus a CRF plus SCR ASC. But in terms of N2, N3, medium and heavy duty, we have a DOC plus a CDPF plus SCR ASC. So we adopt a different technological roadmap to meet the needs of different regulations. And several years ago, let's look at our sales volume in the past several years. There is a big growth. And in 2021, and it is about 4.47 billion. And let's look at production volume. It's around 971. And this is, it makes us #1 local emission control catalyst supplier in China. And in our, let's look at the organization chart. And we have a shareholders meeting, board of directors, and executive management. And we have a SCMD, VMD, IPD, CMD, MD, FCD. And below it, and we have some applied engineering department and the VRND for the post-treatment. And generally speaking, and the overall employee staff is 400, and accounting for 1/3 for our R&D. This is our management certification. Not only the traditional one, we also have the occupational safety, as well as the environmental protection system certification. Now I want to talk about the design verification capability, which includes wash code development history and the laboratory management. Like I mentioned, we develop different technological roadmap according to the regulatory evolution. And we developed and different kinds of post-treatment catalyst. And this is the review of our company's TWC, GPF, wash code technologies from 2016 to 2018. You can see Euro 456, National 456. We developed many generations of WGF catalysts. And in 2016, and for Euro 6 and National 6, and we have CGPF coating. And in terms of diesel engine from 2018, and we developed several generations of DOC coating technology. And in 2020, to meet the requirements of Euro 6 and National 6, we have a WHD 713 CN to meet the National 6. At present, and we have, this is our lab management. We have ISO, IEC, and also we have the certification. And also we get a certification from the General Motors, and this is a GP10 certification from GM.
So in our laboratory, so we see that in the assessment, we have the powder assessment and also the PGM analysis. In the middle, we have the passenger vehicle dyno, and also it is for the TWC, SOC, SCR, and the DOC and NA. LNT reactor. So these are for the passenger vehicles that I know, and the Horiba engine bench, diesel burner, and also the engine aging bench. So these can be translated into the parameters that we can use in the rig test. And on the combustion and on the bench, we also can do the accelerated aging testing. This is for the new energy vehicles and the product that we have developed, including the material synthesis and also for the PMWE and the PMFC. So we have done relative testing and the green hydrogen studies. We have the facilities which are quite developed. The third part is the manufacturing. In this picture, we can see this is the flowing process of our product manufactured from the substance charging to the offline and put into the inventory. We can see every step of the process. The black lines is the physical product processing. The green line is the data flow, and the red one is for the non-compliance is a product and the troubleshooting. Our product process, when it is put online, our substrate will be put into the monitoring system, and we will have this coating and also the weighing before and after the coating. And with calculation, we can have the wet weight calculated, and then we get the wet gain weight diagnosing, the drying and cooling, and the drying weight weighing, the plugs detection, the calcination, and we have the phase mark. So as I have mentioned, in 2016, after this upgrading of our facilities, we have the renovation of our production line as well. And with TWC and FOC, we have the annual production of 10 million. And for the GPF5, the particle capture is 5 million units per year. And for the DPF, for the large scale ones, it is 1 million per year. And also for the SCR, it is about 600,000 units MC and NMC, it is 3 million per year. IEC is 500,000 units per year. So this is for the Pokayuki. That is for the mistakes and the diagnosis. So for the materials, we have the PDA scanning. For the substrate and the slurry, when it will come into the production line, we will identify whether or not it is what we need. And after that, in the process of the production, we have the side mark inspection. We also will look at the wet gain weight and the plugs detection. In and out, we also have the scanning to have the data collection and also the data cross-checking to see whether or not there are other products mixed with it. So the last part is the company's owner and the award and achievement we have got. From 2008 to now, we have got many awards at the national level, provincial level, and also the industry association. In 2011, in the 11th five-year plan, we are listed as a best team in implementing the plan. And in 2017, we were recognized as the Sunan Gasoline Enterprise, which means a very outstanding new and emerging company. So this is our contact. If you're interested, please feel free to contact me with email or with a phone call. Okay, this is my presentation. Thank you very much. Thank you, Mr. Wang. For the vehicle emission reduction and for the after treatment and other technologies, in the past years, we also can see that the testing technology is also developing very fast. This has given great development drive for the testing. So now let's welcome our next speaker. Our next speaker is from Nanhua Instruments of Foshan, Mr. Chen. Let's welcome Mr. Chen, and he will talk about the in-vehicle testing instruments. And could you please unmute yourself and start playing this screen?
现在还没有办法听到您的声音。
喂，听到吗？
Hello.
现在可以了。
大家下午好。
Good afternoon, ladies and gentlemen, and dear experts. I am from Foshan Nanhua Instrument Corporation. My name is Chen Yunli, and I will talk about the vehicle exhaust emissions and measuring products. And just now we listened to the emission control technology part. Our company look mainly at the R&D for the exhaust emission measuring. So I will talk about the two products. One is the non-road mobile machinery, and another is the simplified loaded emission test. And this is our company's brief introduction. Nanhua Instruments were established in 1996. And it is specialized in the vehicle emission measurement. We start from the single product to the system development. And now we provide the whole group of solution. We have the IPR developed by ourselves. This is our R&D center. We have a 90-floor building. We have a headcount of 400 people. And our output revenue is at about 500 million RMB. We have got these certificates, including the ISO 9000 and the quality certification. We also have got the high standard achievements from the responsible authority. We are a high-tech company, and we are also the base of the Guangdong Province Air Pollution Monitoring Engineering R&D Center. We work with a lot of manufacturers, including Mercedes-Benz and also BYD and the other very important and famous manufacturers. We work with the for as stores. So the product we want to introduce to you is the first one, non-road mobile machinery. This is a road inspection emission detection solution. This system is for the road inspection and also for the law enforcement staff for the vehicle on road when they need to have the random testing. This is the emission measurement facilities that they need to use. It has several parts. The first is for the gas vehicles. We have the vehicle exhaust emissions the measurement treatment that is NHA 605P. It uses the infrared NDIR and it can test the CO, the HC, and the CO2 with the NOx, NO, and the oxygen. It uses the electrochemical battery. It is mainly used for the in-road law enforcement inspection. And for the third-party measurement, it is also used. OEMs will also need this instrument when they need the performance testing on the emission control. This is the measurement facility, and you can see the indicators. So we can see with the current standard, we have the national standard. That is for the dual carbon measurement. It is a mobile, can be used in different locations for the road and off-road vehicles. And the data can be stored in the pad, and we can do the data analysis or upload this data onto the platform. And with the testing on the gas engine, we also have the NHT-8P portable smoke oximeter. So it looks at the visible pollutants in the exhaust and the compression ignition engine. It confirms with the technical requirements for the limits and requirement measures for the emissions from the diesel vehicles under free acceleration and lockdown cycle. And it is also for the mobile testing. In the China 3 and China 4, the diesel engines is also under close monitoring. To reduce the NOx emission, there will be a Euro after treatment device. The responsible authority will need the device to check the Euro concentration. So we have the NHNS and to see whether or not it is qualified. We have this detector for the Euro concentration. It can have the real display of the measurement results, and it can be uploaded to the tablet computer. So this will use this reflection method to measure the content of the Euro to realize the quick measurement to see whether or not the diesel engine is compliant. We also have another new equipment that is the portable Ringerman Imitance instrument. So this one is an intelligent instrument. It is used to detect the visible pollutants in the exhaust, and it meets the Ringerman technical requirement for the limits and the measurement methods for the emissions from the diesel engine. Under the free acceleration and the lockdown cycle, it is more suitable for the heavy-duty diesel engines and the off-road mobile machinery detection. Based on the China 4 and China 5. The country also has the special requirement on the OBD diagnosis instrument. For the 38247 and 18285 GB standards, it is required that the OBD should have the road testing to see whether or not the performance of the OBD is qualified. These pictures are the application for the off-road construction machinery and the mobile legal enforcement checking. And second is for the whole vehicle, in-use vehicles emission testing. And you can see this is for the annual testing. We see two ways for the national testing. One is for the transient, another is for the simplified stationary. And whether or not which one is used in different provinces, there might be the different policies. So this instrument can implement the national and local standards for the simple transient emission detection. So it has a specialized measurement device, it has a controlling model, and a multi-level authority function can limit the setting management, and it will have the vehicle drive over this instrument, and the sensors will see the conditions of the actual driving and then give the measurement results. For the emission measurement, it requires that the performance is quite similar to that of the dual carbon, and the accuracy requirement is also high. And compared with the traditional instruments, this one is with a higher efficiency and accuracy. For the chassis, we look at the heavy-duty and the light-duty vehicles. For the light-duty ones, it is below 3.5 tons. And for the heavy-duty, it is over 3.5 tons cab mass. And on the different rigs, we will mimic the road driving conditions and test the emission result. The indication and the specification includes the CO, CO2, oxygen, and the nitro oxide, and also hydrocarbons. For the nitro monoxide, we use the NDNR. As I previously mentioned, the dual carbon, the NO, it uses electrochemical. So this is the different technology route. For the heavy-duty diesel engines, we have the heavy-duty dynamometers. It has the rear axle and the dual axle dynamometers, and we can have the rig test. For the simple working condition measurement of the emission, it is developed by ourselves, including the hardware and the software. In the application of this system, it is mainly for the annual inspection stations for the vehicles. In the locations carrying out the annual inspection, it is widely used. So you can see these other pictures for the application scenarios. In every city, there will be the regular annual inspection station. And the method they use includes the simple stationary, static, or the simple transient conditions. And they can all use our measurement facilities. We have over 20 years measurement and inspection service experiences. We hope that with this conference, and if you are interested in the product we provide and the solutions is suitable to you, please feel free to let us know, and we can do the tailor-made designing and the individualized solution development. We are also OEM for the Bosch facilities. For the quality control and the stability of the quality keeping, we have got preferable recognition from the major OEMs. I also hope that you can have opportunity to work together with us. Thank you very much. Thank you, Mr. Chen. Thank you very much. And I would like to thank everyone for your wonderful presentation. And now we go into the Q&A session. For the participants, you can type in your questions on the chatting box. You can also raise your hand and directly raise questions to our presenters. Both ways are okay. So I want to first check if you want to raise your hand. If not, I will read the questions in the chatting box.
At
present, I do not see guests raising their hands. Later in the QA, if you have any question, feel free to raise your hands. And first of all, I noticed one question on the power sector. And so why not? We can invite the 4 speakers from the power sector to answer this question. This question is that China proposed 2025, the average coal consumption is 300 gram, and that is average level. So to the thermal power or coal-based power company, what will be the challenge and how to get a technical preparation? Why not I have Professor Wang to answer, and then followed by other power companies delegates. Hello, Mr. Wang. Sorry, I missed the question. Would you please to repeat the question? Well, this question is that by 2025, the coal consumption is 300 standard coal per kilowatt hour. So what will be the challenge to the coal-based power company, and what will be the technical preparation? Okay. I think this challenge, to myself, I think this is not very big challenge. Why? By now, the power technology, I mean the power company's technology, the development trend by 2025, such a goal, and this goal is not very high or very stringent. And because when stipulating the goal for 2025, it already considered the technical potentials, especially when the efficiency, at least theoretically, is very close to theoretical limit. It is more challenging. That's why in stipulating the goal of 2025, we already have this consideration. When setting up the goal, and that is a full loaded operation, and it is not all the time, but in a full workloaded conditions, and then we have the test. However, in the future operation, especially when we have a flexible regulation, and in most cases, it is not a fully loaded. operation. If we test in full loaded plus conditions, I think that's no big problem. We need to have several factors into our consideration because we have some supercritical foundations, and we need to have even you can not make it supercritical, but you can enhance your efficiency to get close to the supercritical, and there is potential there. The other thing that is a thermal power cogeneration. And when we increase the percentage of thermal, which means a higher efficiency, and the coal consumption in generating electricity, how did we calculate the efficiency? We already put the thermal efficiency into consideration. And that is how we implemented our goal. And I want to elaborate here. It's not a good idea to pursue efficiency only. I often say this on different occasions. Whether it can flexible regulation so that renewable energy can have a better development. We also need to consider its economic benefit. And we cannot simply pursue these high parameter or high capacity. We need to think about the functional repositioning. So 300 gram coal and other requirements, we are able to reach that goal. But more importantly, in China's strategic plan, in the 14th five-year plan, the ecological construction in China is focused on the carbon reduction. Another is a high quality development that is a high economic benefits, high energy efficiency. So, and you know that energy efficiency is the physical parameter. You also need to consider the economic benefits. And this is my understanding of this question. Okay, thank you, Professor Wang. You talked about high quality and high efficiency and high economic return, which are very key words for China's next stage development. And how about the coal consumption for power generation? And what is your feedback to this answer, to this question? If no further answer to this question, we have one quick question to Professor Wang. And China is quite leading in the coal-based power stations emission. But now, for the double carbon requirements, maybe the requirements will become more stringent. So how about PV and wind power and zero cost comparison to the coal-based power? What do you think the cost difference in terms of promoting the PV and the wind power? What are the problems ahead of us? And this is a very good question. I want to talk about this first, because in the future, we cannot only simply focus on one single energy. For example, the wind power and the PV, the on-grid cost is very low now. Sometimes it is even lower than the coal-based power station. And people say, why not we totally replace coal-based power station? You need to be aware that when it is used by the users, the total systematic cost plus the on-grid cost. In the future, the power generation, regardless of coal or others, you need to consider the systematic cost. Before the users, all the systematic costs should be considered. And then we need to consider which one is better to you. And I often say this. And for example, and in operation, and it consumes a lot of coal. For example, 30 or 20% load, the coal consumption is very high. However, it is not caused by coal-based power company. That is to provide flexibility to the whole system. That's an extra cost. Therefore, in the terminal users, you need to consider contribution made by the coal-based power station. And then you need to think about the PV and the wind power. To some degree, they also need to shoulder the systematic cost. Without shouldering the flexible regulation cost, okay, you build the PV and the wind power, you need to have your own energy storage capacity. You know, energy capacity, storage capacity is expensive, sometimes 20%, but in the operation, in reality, seldom do we use that stored energy, which means that the power generated between different regions at present, and it is in faster process, and this is in a process. And anyway, the direction is quite clear. No matter it is PV or wind power, you need to have a higher efficiency, lower cost at the same time. In some places, you need to cooperate with the energy storage. And a coal-based power station not only consider efficiency, but also flexibility. And generally speaking, in the future and in the new power system, and they need to have a systematic consideration, and you cannot only consider from one aspect to solve everything. I don't know if I have answered this question. I know this is a very complicated question. Okay, very clear answer. And if you have further question, feel free to type in your question, and then we can offer your answers in the chat box. And several other questions on the vehicles emission. And Mr. Ni and Mr. Chen, do you have any ideas on this question? And feel free to answer this question. And in a Philippine city, there is a Jeep, a small modernization plan for the local bus. However, many people cannot afford such a new vehicle. They can only use the old vehicles. Do we have any new equipment or technology to reduce the emission from the vehicle to meet the target? So this is the description of this question. Mr. Ni, would you please try to answer this question? Mr. Ni, are you there? Internet connection issues. How about Mr. Wang from Yuchai Company? Are you still online? Just a second. We need to check the internet connection. Hello, Mr. Ni. Hello, Mr. Wang. Can you hear me? Okay, we cannot get connection with Direct Ni or Mr. Wang. How about Mr. Chen from Nanhua Instrumental Company? Yes. So would you please repeat your question? What is your question? So in Philippines, a city in Philippines, and they have a modernization plan for a small bus. However, the emission from this bus, do you have any instrument or technology to help this bus to lower emission? So it's about the vehicle emission inspection, and can you offer some suggestions? Well, and our R&D direction is on the emission inspection. Whether the emission exceed the target or exceed the emission, they can use our instrument for inspection. And maybe the local government of Philippine city support the bus or They want to use this technology to phase out these high emission bus. So seemingly this question is that they want to replace them by the new ones. However, they cannot afford it. That's why they keep using the old ones. So in terms of the old ones, and can we keep them and to make them compliant with the emission level? I think that they can work out a emission limit. With the emission limit, by technical method, and you can keep your emission within the limit, okay, you are allowed on the roads. But in case that your emission is above the limit, and maybe we can phase it out. And we have a similar policy in our country. Thank you. Another question is given to you. You talked about inspection instrument for petrol and diesel engine. Is it very demanding for the operator? What are the maintenance in the day-to-day life? Is it very expensive? No, because we have a operational manual step-by-step, and after a simple training, they are able to handle it. Okay. And talking about these Jeep emission technology, probably we can contact Director Wang and Mr. Ni to offer you a very detailed answer. And also we will share the answer on the official website of this conference. And you can get access of the information as well as the website in the chat box. Well, we finished the session 1 and the session 2. And I really want to thank all the speakers for your wonderful sharing as well as your engagement in the meeting. And before we have the break, I'd like to invite Evelyn to introduce our post-event survey.
Hi, Evelyn. Can you hear me?
Evelyn?
Thank you very much to everyone for staying until the end of our session. We're very glad that you are here learning with us, and we hope that you have gained a lot from the lectures. What we are now doing is launching the poll for the post-evaluation. And this is important so that we can assess how much you have gained because of the lectures. So it is already now shown in your screens. We appreciate if you can just click again on how you would assess your knowledge on the different topics that we have discussed. And again, you can just click on the choices, and we'll wait for a few minutes to give time for everyone to answer the poll. As just like in the pre-meeting evaluation, you just need to select 4 if it's the highest level of knowledge that you can assess yourself with, but 1 if it's on the lower end of the scale. This is important so that we know how further we can improve future events that are similar to this. And we hope as well that you have learned significantly in comparison to the start of the session. Right now, the numbers are increasing. Thank you very much. So we'll just wait for a minute for everyone else to provide their responses. So now we have around 24% of our participants answering the survey in your screens. Just a few seconds more. We hope at least a minimum of 50% answers, 50% participation. We're glad to see that there are different benefits that you have gained from the workshop. And we aim to continue doing this, and we will keep this in mind when we develop further similar events. So just a few more. We now have 10 participants who have completed the form. Just a few more seconds. And while the rest are answering, we would just like to remind you that we will provide an email at the end of everything so that we can provide you the links to the materials and then to the platform as later will be shared once again so that you can be updated as well with what has happened with the event, the materials. And with this, I will now close the polls. Thank you very much for your participation.
不是。
好的，Evelyn， Evelyn，are we finished with the survey？ 好的，谢谢大家对这个会后评估问卷的这个
Thank you very much for your participation. And that's the end of session 1 and session 2. Now we have a 10 minutes break, and during the 10 minutes break, and feel free to our technology fair.
Recording stopped.
And you can have
Recording
more
in
information.
progress.
And after 10 minutes, we have a closing plenary. That is 5 o'clock. And from now on, we have 10 minutes, and then we will have a break. Thank you for your participation.
Thank you, everyone, for joining the closing plenary for the event. From this, we would like to invite our TA team leader, Ben Grebo, to provide us with a quick closing and some reminders as well in relation to this event and the project. Over to you, Ben.
Thanks, Dang. Sorry, I couldn't unmute myself there. Good afternoon, everyone. My name is Ben Grebo. I've met many of you before, but just by way of introduction, I'm the overall team leader for the TA through which this event has been organised. And I just want to really provide a bit of a wrap up for the last 3 days before we close. So we won't keep you much longer. So we have heard a lot of information over the past 3 days. We started with the policy level approaches to air quality management, both at a national level, but then really honing in on specific cities. Yesterday, we then got down to specific sectors and trying to understand the policies, standards, and good practices for individual sectors. And then today, we've really delved down into the detail of specific technologies for each of the sectors that we focused on. And there's a lot of information, even more information on the platform to go with this. So I hope that you found it useful and that this has given you things to think about. For our 7 cities, which we are developing cleaner action plans under the TA or roadmaps to cleaner action plans, there are a series of follow-on activities around technology and policy training, where we'll be looking more targeted at a sort of city level as to where there'd be most benefits of delving into more details. So those are still to come and further details will be provided. So I'd like to start with some thanks. First of all, thank you for joining and all of the participants. A particular thanks to all of our experts, technology suppliers, and other speakers that we've had over the course of these 3 days. I know a lot of effort has gone into preparing presentations, preparing materials, and I hope that you found that all very useful. I know I've certainly learned a lot over the last 3 days. And of course, a big thank you to our colleagues at Clean Air Asia for all of their efforts in organising, designing and running this event, and also for setting up the platform. I think we can all appreciate that a lot of effort has gone into the delivery of this, and I hope it has been valuable. So for the platform itself, I just wanted to remind everyone that will remain open after the event, and that includes the Q&A section of the platform. So please keep any other questions, comments, etc., that maybe have only come up after the event that you've thought about, or things that perhaps we didn't get time to discuss over the last few days. Please use that for that. But also recordings of the events, of the sessions, sorry, and a series of sort of technology flyers from many of our different suppliers are all available for download on the platform. So I would encourage you to interact, to go there, to visit and see what information is available and how that may be useful for you. I'd also encourage you to share that with your colleagues and other stakeholders within your countries and cities, because I think this could prove particularly valuable. In the future, the platform and the materials will be moved onto a separate platform, but further details will follow on that in the near future. But for now, it will be available, and we hope that you can access it and make the most of the materials there. Another, I guess, reminder is that as part of what's termed the Asia Clean Blue Skies program, so this is a program whereby ADB are looking to increase and improve their investments in improving air quality via specific investment projects and programs. We've been running a series of knowledge sharing events, and the next knowledge sharing event will take place on June the 15th. And that will be focusing on city level air quality monitoring strategies. Link has been provided in the chat. Even if you can't join on that particular date, then the recording and slides will also be made available. So I certainly encourage you to register and keep an eye out for that, because I'm sure that could be of interest to many of you. There's also been previous events focused on specific sectors. And again, we can provide details of where to access those materials. And also after this next event, there will be further events to come. So again, watch this space. So I think that's enough of my prompts, reminders. Thanks for today. It's been obviously a very busy 3 days, so I don't want to keep you any longer. So with that, I would like to just thanks again to all of you and wish you a good afternoon and evening, and look forward to our continued collaboration. Thank you, everyone.
Thank you, everyone.
Thank you, everyone, for joining us.
Recording stopped. Recording in progress. Recording stopped.